Hello everybody, welcome to our lecture on map making in ArcGIS. This lecture will include a brief introduction to basic cartography, and we'll discuss some guidelines and general strategies we use for making effective and interesting maps. Now, maps are definitely an art form. I wish we had the time to really study cartography in this course because there's so much to it and so many ways you can go with it. It's just far too large a topic to cover in an hour, though. You can't teach cartography in an hour any more than you could teach writing, painting, or music in an hour. We're going to do what we can, though. We're going to cover several common map components. We'll discover how to make maps in ArcGIS, and finally we're going to talk about a few good data sources you might like, especially in ecology and forestry. And I'll talk about a few good professional sources and some professional societies that you might be interested in. Now, in ArcGIS, we have a lot of options open to us in our maps. We can use existing base maps, such as these USGS topos, are readily available to us, and these topos especially are some of the most commonly used maps available for land management and ecological research. They are a fantastic resource. We can use imagery. We have lots of image sources at our fingertips and often at pretty good spatial resolutions. We even have several imagery sources such as Landsat and NAIP, which can show us the imagery at different times in history, so we can look at change over time. A lot of these sources even provide imagery taken at non-visible wavelengths, so we can analyze forest health and a lot of characteristics of the landscape that are not readily obvious. Now, making maps can also just be a lot of fun. Sometimes different phenomena just look cool. For me, this map of solar duration, this is a number of total hours that hits the landscape in the year. I just think it looks neat. It looks sort of spooky and stark, and I don't know, it's just got a neat quality to it. Sometimes you can tell interesting stories just by the way you symbolize the data. So this is just a DEM with a hillshade behind it, but I took every elevation below 2100 meters and I shaded it in deeper colors of blue, so it kind of gives this illusion of water. Just a way of symbolizing the landscape. Now let's look at a number of common map components you often see on maps. And before I get into this, I want to point out that there really are no clearly defined rules for what makes a good map. You know, people love or hate maps just like they do any other work of art. Personally, I like adding hillshades to most of my maps, same way you see in these slides, and just often as kind of a low contrast background layer, and to me just gives the maps a sense of depth. Other people probably disagree, and in fact there are differing schools of thought about what makes a good hillshade. Some people think the hillshade should be smoothed over to de-emphasize topographic details, and I disagree, but that just means different people have different opinions. So these map components we're going to discuss, they're often good to add, but there's definitely exceptions to every rule. Now here we're going to look at scale, we're going to look at legends, we're going to look at north arrows, reference maps, titles are good on a map, an area of interest, how to steer your viewer to look at the region that you really want them to see. You often want to put projections and datum information on a map. Grids and graticules, these are just ways of adding reference lines to a map. It's often good to know when the map was made, who made it. If the author or the organization that produced the map has some identifying logo they'd want to put on there. Descriptive text explaining what's going on. Data sources, it's always good to cite your data, and sometimes we add little various things like graphs, tables, and reports. So these items are commonly seen on maps, are usually good to add, and in most cases they make your map easier to understand and use. As I said, there's exceptions though. Now our end goal is always to make a map that communicates well. Now if we want to communicate vegetation types over a study area, for example, we may not want to clutter the map up with contour lines or reference grids. If we want to show roads and trails, it may not be a good idea to use aerial photography because there's so much extra detail in the imagery. Sometimes you just want a map that is clean and simple, almost like a cartoon, telling a very basic story without a lot of background references. In this example, this map has no scale because the scale changes drastically over the vertical extent. Has no north arrow because north is obvious. However, it does have a title, a legend, spatial reference, descriptive text, a logo, and the author. Now, this type of simple format is especially useful when you plan to present a series of maps, all showing different statistics over the same area. This particular example is one of several maps showing global aquaculture statistics for FAO, and getting a nice basic template like this is really useful when you have to make a lot of maps, because this allows the reader to get comfortable with the formatting in one map. Then the rest of the maps are just that much easier to understand because the basic format doesn't change. In this particular example, I made about 700 global climate change maps, and they all follow this exact same format. Now, how do we draw a user into a particular area of interest? This is often referred to as the AOI, the area of interest. It's the region you want the viewer to focus on. It's what you really care about. And it's often not this rectangular shape that the map itself is. You have to figure out a way to draw the viewer in. So here the story is about dams and rivers in the Colorado River Basin. So this is the entire region that drains into the Colorado River and all the tributaries. And so we cared about that basin, so we put that in color. We made a nice boundary around it. Then we put the rest of the states outside of it, but the states sort of fade off into the background. And then there's a little inset map that places the basin within the overall Southwest. So it does draw your attention right to the area we care about. Now here's another example of how we draw your attention to a particular area of interest. It's not a pretty map. It's not one of my favorites. Tells the story it needs to, though. Now, this is a map of fire severity and extent over a set of California's spotted owl territories in the San Bernardino Mountains back in 2003. This example, I made a large single polygon that covered the extent of the map, and then I cut a hole in it over the area of interest. So that portion you see that's a little darker, that's actually the hole in the polygon. Then made the overall polygon semi-transparent, which has the effect of washing out the area outside the AOI, but not removing it completely. Now, this example also illustrates what we call a measured grid, which is a type of grid that follows projected coordinates, and it's UTM lines in this case. I like this map better. I often put my AOI in color, and I leave the outside in black and white. So it really brings your attention to New Mexico in this case. This particular map was a really interesting case of a spotted owl that we had trapped back in 1999. This was an adult owl. It had mated, it had reproduced, and then the study was over, so we left. But it had bands on it. So they found the owl dead up near Cuesta in northern New Mexico 13 years later. So weird in a lot of respects here. An owl usually doesn't move when it's settled. It mates and it's kind of there for life. Now this guy, actually it was a female, it moved hundreds of miles after we had seen it last. Strange situation. Now here's another example of coloring the area of interest and putting the outside in black and white. And like I said before, I always like topography in my maps. It just, to me, it kind of places me and makes me feel good. So ArcMap gives you a lot of tools to really define your AOI in different ways, and in this example you can actually clip the entire map to some polygon that represents your AOI. There's lots of nice features about this, and you can create scale bars, north arrows, grids, etc. that are actually linked to the map. So you create the thing, and then if you change the map, all these linked items also change. The scale bar changes if you change the scale, for example. There's also some sophisticated text tools, such as letting you fill an irregular polygon with text that you see here in the lower left corner of this map. So this map is really similar to one that you're going to make in lab exercise 2, so you get good experience with how to do this. Now let's talk about reference lines. Just ways of placing extra information on a map to help the user know where they are. So there are three common grid types that we often put on maps. Now, this first one is called graticules. It's just a grid of lines that follows latitude and longitude lines. So here you see a map with lat longs along the edges of the map, and the dashed lines represent the intersections of these lat long lines. You also have measured grids, which are exactly the same as graticules, except they follow projected coordinate systems. So here's an example of measured grids on that same area. In this case, we're looking at UTM coordinates. So understand the difference between graticules and measured grids. Graticules, here we go, graticules follow lat long line. Measured grids follow projected coordinates. Otherwise, they're exactly the same. Often we actually put both of them on a map. The USGS topo maps are famous for this. They have lat long lines as well as UTM grids all on the same map. There's no reason not to. ArcGIS offers a third type of grid system called reference grids, which is basically a bunch of arbitrary tiles on the map. You have letters along one axis and numbers along the other axis, and if any of you ever played Battleship, this is basically the Battleship strategy. Reference an area by, say, go to cell D3, and you know right where to go. There's another type of reference line that you don't really see much anymore. They're called RUM lines. They're lines of constant bearing, and you mostly see them in ancient maps. And these maps helped ancient cartographers draw accurate maps. The lines themselves and those center points, those circles that you see that the lines come out from, those locations don't really mean anything cartographically. It's not like there's a city or a special location there. These are just sort of random sites on the map the cartographer used to draw from. Now this particular example is a map of, it's called the Portolan Atlas of the Central Mediterranean by Joan Oliva from 1590. So it shows these RUM lines following these lines of constant bearing. Like I said, they helped ancient cartographers draw maps. They're cool looking, but they're not really useful anymore. They're mostly of historic interest. And it would be really tough to make these in ArcMap. There's no standard tool to do it because really, most professional cartographers these days don't need them. You could make them. You could make a tool that would draw them, and it might be kind of fun for graphical interest. But so they're neat, but like I said, they're not really used much anymore. When we prepare a map for a report or a presentation, it's not unusual to use multiple maps to tell a single story. So foresters might present a set of maps to illustrate consequences of different land management options, or city planners might present multiple maps to show the expected growth of urban areas over time. This particular example is a part of a single poster that shows expected changes in temperature and precipitation in southwestern U.S. given current climate models. It's nice to be able to set all maps side by side so we can get a sense of the larger story. Now, inset maps are a common way to use multiple maps to tell a single story. We often want to add an inset map to either give a frame of reference or close-up or even to show other areas, and I'll show you some examples of that. But this inset map provides a frame of reference for the primary map. Primary map shows a close-up of the San Francisco peaks. The inset map shows where the San Francisco peaks lie on the larger landscape. This example uses an inset map to zoom in on an area. We see all of northern Arizona in the primary map. We see how Flagstaff is laid out in the inset map. So road atlases use this method a lot. This example uses an inset map to show other areas. So our primary map tells the story we're wanting to tell. The inset map shows that the same phenomena occur in other parts of the world. In this example, we wanted to show suitable areas for marine aquaculture in Southeast Asia, where these dotted lines represent the exclusive economic zone boundaries for each country. The report was all about the potential for marine aquaculture per country in Southeast Asia and Northern Australia, but the inset map, we could also show that these regions existed elsewhere in the world without really distracting from the main story that we were trying to tell. We've been discussing a few common map components, and it's true that many map components like scale bars and north arrows are almost always included with maps. But remember that your goal here is not to satisfy a set of rules, but rather to tell a clear story. And usually throwing in a scale bar or a legend helps to tell the story, but there are exceptions, and sometimes these map components don't help tell the story, but they actually distract. It can sometimes be a difficult judgment call to make, but if a map is better off without them, then by all means don't add them. So the general rule is that certain map components should almost always be added to maps, like scale bars, but there's always exceptions. And we almost always want a scale bar when we map our survey areas or analysis areas, management zones, but sometimes scale bars are not appropriate if the scale changes a lot over the map. North arrows are often left out just because we usually assume that north is to the top, but sometimes they are nice aesthetically. You should definitely add a north arrow if north isn't at the top. Remember that you can always rotate your map. Sometimes the things we want to show just don't fit well when the map is oriented with north at the top, so rotating allows us to zoom in and see everything better. And in some cases, rotating just lets us make more efficient use of our map space. But if you do rotate the map, definitely add a north arrow. If you don't, your reader's just going to assume that north is at the top, and that'll just lead to confusion and frustration later. But sometimes the map itself just isn't appropriate for a north arrow. This particular coordinate system, north changes all over it, so there's north arrow really wouldn't be appropriate here. So here's a couple of maps I made for FAO, the United Nations Food and Agriculture Organization. So they wanted to show sub-Saharan African countries with significant marine aquaculture. And for some maps, they wanted countries' names. And notice that in these maps, there is no scale, legend, or north arrow. There is an inset map that draws your attention to a particular region in Africa. For other maps, they just wanted regions distinguished by color, with no text, references, scales, north arrows, or anything. Just clean and simple maps. These make nice illustrations and sometimes headers to documents. Now, sometimes you just want a map to be graphically interesting without really intending it to be used for any type of analysis. So this is an example of a map I made to serve as just background to posters. It's kind of a map that just makes me start daydreaming. This particular map is one of my favorites. It's Saul Steinberg's A New Yorker's View of the World. Makes me laugh because it shows the basic New Yorker's lack of interest in anything that's not New York. Everything up front is nice and clear and distinct. Then there's the Hudson, and everything past that just sort of fades together. Let's discuss a few guidelines as you make maps in ArcMap. So first off, the main feature in your map should definitely be the largest. Whatever it is you're wanting the person to notice should be the thing that first catches their eye. Next, if you want your viewer to look at your map elements in a particular order, like if they form parts of a larger story, you should arrange those map elements the way a person would typically read a document. So in the United States, you'd expect the person who sees your map to review it from left to right and then from top to bottom. But if you're making maps for folks in Israel or in Arab countries, you might arrange the map elements from right to the left. In some Asian countries, in China, Japan, and Korea, for example, especially in more traditional societies, you might design the map to be read primarily top to bottom and secondarily from right to left. Then definitely use colors that make sense. Don't map riparian or water areas in red, for example. This is a really common mistake. People add a layer to ArcMap and they just accept whatever default color that is, no matter how ridiculous and non-intuitive that color is. So, use some common sense. So anticipate color blindness, and remember that it's a really common condition. Our eyes actually perceive light similar to the way the satellites take multi-band images. So you remember that satellites have they take images in the red, green, and blue bands of the spectrum, and as well as in a lot of infrared. Well, our eyes kind of do that same thing. We have 3 types of cone cells in our eyes that detect light, and each type is most sensitive to a particular frequency. So they overlap a lot, but in general we're sensing at 3 frequencies, and our brain converts that to the colors we're used to. So there's a lot of people who have a condition in their eyes in which 1 or 2 types of cone cells may not be working correctly, or else 2 types are just too similar to each other, sort of, especially with the L and M cells you see in this image. And when this happens, basically the L and M cells are seeing the same frequency, so the person can't really distinguish between these two frequencies. Therefore, their brain is basically working with two wavelengths or just a single wavelength. So if the brain only has one wavelength to work from, then basically that person is seeing in black and white. And if the brain can only perceive two frequencies, then the problem is just that they can't resolve certain colors. And most people with color blindness have the L and M cells just too close to each other and therefore can't, or at least they have difficulty with distinguishing between red and green. But just remember that nearly 10% of the population has some level of this. So try not to make maps that are unnecessarily difficult for these folks to read. And you can anticipate this fairly easily and make simple adjustments to your map that make them viewable. And be careful going overboard with imagery. Imagery is tempting because it's so pretty and you just want to throw it in there and it captures your imagination. But this imagery can be overwhelming too. These types of maps usually do not communicate a story quickly. The imagery just overwhelms everything. Now there is another issue with Esri base maps. It's not real obvious. They don't often export at a very high resolution. So even if you export your map at a very high DPI, the background base map imagery still comes in kind of fuzzy. It's just fuzzy at a high DPI. So your printed maps end up kind of pixelated. So there is a workaround, and let me demonstrate that for you. So here's the situation. I have this imagery of the Little Colorado River drainage as it meets the Colorado River at the confluence in the Grand Canyon. Here's the LCR coming up through here. Here's the confluence with the Colorado. So I want to export this image at a high resolution. So if I zoom in, I can see details in the imagery. I know that the Esri base map image service does have very high resolution. If I actually zoom into the image itself, it's beautiful. There's tremendous amounts of detail in that image service. So how do I capture that high level of detail in an exported map? Now, right now the map is set to be an 8.5 by 11 image. So I'm just go to File, Export. And my first idea is just to export at a very high resolution. That should allow me to capture a lot of detail in that imagery. So I'm going to go with the 600 DPI image. I'm going to do JPEG just because that makes manageable file sizes. I'll call this the LCR at 8.5 by 11 at 600 DPI. So the image has been exported. We just go and open that up in Photoshop. And here we go. It looks good so far. It's at very high resolution. So if I zoom into a particular area, unfortunately I see a lot of pixelation of this image. If I scroll around and zoom in a little bit deeper, well, I see the pixels there, but everything's really fuzzy at that resolution. So I have lost some of the detail I wanted to get. And there's just really no way to recapture that when you export this base map. The base map has higher detail behind it, but it just doesn't export at that higher detail. So the workaround is to make our layout larger. Now I'm going to create a spatial bookmark right now so that I can get back to this exact same extent of the map. Create a bookmark, call it LCR for Little Colorado River. Okay, so we're going to make the layout larger. I'm going to make the layout poster size. You put your mouse off the data frame, right click, and go to Page and Print Setup. Here we say we're not going to use the printer settings anymore, but we're going to set our own. We're going to have a width of 33 inches, that's 3 times the current size, a height of 25.5, again 3 times the current height. So the image is now going to be 3 by 3 larger, 9 times as large as it used to be. So the layout immediately gets set to that size. Our data frame is still down here at 8.5 by 11. So now we have to make the data frame fill the layout. You could do it manually. You could select it and drag a corner. And that is a method. I like to just right-click on it, go to Properties, and manually set the size to be the exact same as the layout. We say the lower left corner is going to be at the lower left corner of the layout. We had that by 0 inches by 0 inches. The width is going to be 33 inches. The height is going to be 25.5. Hit OK. And the data frame now expands to fit the entire layout. Now it's still at the same scale it was before, so we're going to have to use our bookmark that we just created and go to the extent of the little Colorado River. It takes us back. So now it looks sort of like it did before. We're going to export it again, but remember this time is from a much larger page. This page is 33 by 25.5, not 8.5 by 11. This time we're going to export it at 200 dots per inch and not 600. I chose this new DPI for a specific reason. Now, remember that we increased the layout size by a factor of 3 times horizontally and vertically. With this new export, I'm setting the DPI to be 1/3 of the original DPI. This means that the new JPEG image will have exactly the same number of pixels as the original image. Now, comparing the two images will demonstrate how this larger layout size gives you more detail in the final exported image, even though they both have the exact same number of pixels. Okay, we're going to export it to the same folder. I'm going to change the name here a little to indicate the new dimensions. Got 200 DPI. It's a JPEG again. We wait a couple of seconds. Okay, it's finished. So we go to our folder. Here's the new one we just made. We're going to open that up in Photoshop. And here it is. Now we have our original 8.5 by 11 image on the left, our new 33 by 25.5 image on the right. Now they both look about the same at this resolution here, but I want to zoom into a spot just to kind of give you a sense of how much better this new one does at preserving the original details. So let's zoom into the confluence region. I'm just right up in here. We're just going to zoom right to that little blot. Here's the confluence. Come back to our new image, zoom to that same spot. Here we go. Now notice how much sharper the one on the right is than the left. And these images each have the exact same number of pixels, the exact same resolution to the file itself. But by setting the page layout to be a larger layout, then we preserve a lot more detail from the original base map imagery. Okay, let's get down to the actual act of making maps in ArcMap. ArcMap does a really good job at making it a good looking map. It provides a lot of components to make things like scale bars and legends and north arrows in a way to make them look pretty attractive. So you can make a decent map in ArcMap. Just a heads up though, if you really want to take it to the next level and make a beautiful work of art, often you start it with ArcMap, you get the basics, then you'll wind up taking it into Photoshop or Illustrator or something to really fine tune it. But we're going to just look at the ArcMap part of it, which does an awful lot of good stuff. It all starts in the layout. You construct and compose your map in the layout. Each data frame in your map document makes a separate map in your layout. This is how you get the inset maps or the multiple map things that let you tell a more complicated story. There are several things in your map that are linked to the data frames. Whenever you add a scale, a legend, north arrow, grids, or dynamic text boxes, all of these things are actually linked so that they change automatically if you change the map. This means that, for example, if you add the automatic text that tells you what coordinate system your map is in, then you change the coordinate system of your map itself, well, that text changes automatically. So do legends, so do scale bars, so do north arrows. Now you can have multiple scale bars. You can have multiple any of these in your map. You see scale bars a lot where you have you might have a scale bar that might be in miles and another one in kilometers. So yeah, you can add multiple scale bars. You can add multiple legends. This kind of lets you develop a more complex legend where you might have half the legend on one side of the map and the other half on the other, you just add two legends, and then you add different layers to each legend. Now, adding a map element, any of these elements like scale bars, legends, etc., it's easy. You just go to the Insert menu item and you scroll down to find that single object you want to add. So the trick here is that you have to have the right data frame active. For example, suppose I've got a map of Flagstaff, which you see on the left here, and then I have a map of Arizona on the right, and I'm using this little red dot in the map of Arizona to show where I am in this larger map. So this is just a reference to show me where this larger map exists. So suppose I want to add a scale bar to this. Well, ideally, I just go to Insert, I go to Scale Bar, pick one that I like, hit OK, comes down here, OK, easy enough. This is 1 mile. That's what scale bars do. So all was well in this example. The problem, the mistake a lot of people make is they accidentally have this data frame active when they make the scale bar. Remember, when you make a map element, you insert a map element using this insert. The element that gets added is linked to the active data frame. So I add my scale bar again, put it down here. All of a sudden it says it's what, 1,000 miles across. So this is a mistake. So I have my scale bar up here and it's telling everybody it's 1,000 miles across South Campus. So this is obviously wrong. It's up to you to catch that. The problem was because you made it when this data frame was active. So be careful about this. The same applies to all the map elements. So they are hardwired to the currently active data frame. If you like, ArcMap does come with a number of templates that provide lots of these map elements in a standardized format to get a particular looking scale bar and legend. Now, we're not going to use these in this class, but they're available to you if you would like. And if you go to work for a major corporation, they might prefer that all their maps look pretty much the same, and so they would make their own template, and then they would require you to use them. So you get to the templates in the Layout toolbar. You just click that button, the Change Layout command, and then you can open the Select Template tool, and you see all the different options available to you. Now here's something that came out with ArcGIS 10.1. Esri realized that people were having trouble citing the data that they were using, so especially when it comes to the base map layers. Somebody spent a lot of time creating those base map data sets, and they or their corporations ought to be cited for the work they did. So you use that imagery data set. It'd be kind of nice to say who produced that imagery data set. So Esri came up with a method to automatically add that data to your map. When you make a layout, you have this automatic text that says the citation information for these base maps. So it's convenient, and if you like it, then it's great. It makes it much easier. Not everybody liked it, though. Not everybody liked the fact that Esri was suddenly sticking a bunch of text in their maps, and maybe in a way that didn't look very good. And so and you should know that you can remove this if you like, and it's not obvious or well advertised how to get rid of it, so I'm going to show you how to do it right here. Let me demonstrate it for you. So here I am with a map of Lower and Upper Lake Mary. I'm all set to do some work with it. Want to print up a nice looking map with it, and I see that Esri, the ArcGIS, has added this text to the bottom right corner that gives me all the citation information. Well, this is nice if this is what I want, but it might not be. This might not be, this might just ruin the aesthetic effect I'm trying to create with my map, and it often does. So I would like to get that citation information out of there. The way I do it is I go to the Insert menu, go to Dynamic Text, add Service Layer Credits. Now this is interesting because it takes the citation information and turns it into a graphic. Now, I can't actually delete this graphic. If I select it and hit the delete key, it just appears back down here in the bottom right corner again. But what I can do is I do insert dynamic text service layer credits. It becomes a graphic, and I can just drag the graphic off the map. Now when I export the map, it exports without that citation information there. Okay, and that does it for our introductory lecture into basic cartography and how to make maps in ArcMap. When you get to the labs, you'll see lots of instructions on how to actually do these things, so it should give you some good experience in the little methods and techniques you need to take. I wanted to show you a couple of slides of some other sources, data sources, and professional sources that you might be interested in. As for data sources, this National Elevation Dataset is one of the best data sets I've used. It's elevation data for the entire country. It's at this link. You might have to go to the PowerPoint slides or the lecture lab notes to actually be able to copy and paste these links out, so make sure you have those available. I also recommend the USGS Earth Explorer. There's just a lot of national level data on there. The U.S. Forest Service Region 3 data, if you are in Arizona or New Mexico and plan to work with the Forest Service, this is a really nice site for pretty much almost all the data that they have available to them. So you have stand types, you have roads, rivers, hydrologic data sets, grazing allotments, all that good stuff. Then there's a larger Forest Service data clearinghouse. This has national level Forest Service data. For those of you who are interested in fires, fire research, fire management, these 4 data sets are among the best data sets available for fire behavior, fire burn severity for the last several decades. The burned area emergency response, the monitoring trends in burn severity, this ravage, what a great name for a fire data set, the rapid assessment of vegetation condition. And then land fires, a wonderful data set. It doesn't have fire data specifically, but it has fire modeling data, so it gives you data sets on canopy structure and canopy cover and vegetation type. Boy, it has just all sorts of data available. And there is an optional lab exercise that shows you how to use land fire. I really recommend you learn about that. For those of you who'd like to take a class that's specifically targeted at GIS for fire management, this is a class that's available for those who want to join incident management teams as the GIS specialist. So it looks like a pretty neat course. I've never taken it, but the description looks really interesting. Some other general professional resources. Esri has a forestry GIS group you might want to look into. The Wildlife Society has a GIS working group, it's the Spatial Ecology and Telemetry Working Group. There is a Society for Conservation GIS, which is made up of people who use GIS for ecological analyses and management. If you're into remote sensing, raster analysis, and imagery analysis, you might look into the American Society and the International Society for Photogrammetry and Remote Sensing. They both got some good journals too. For just mapping, if you like cartography, there's 3 societies here that are just about cartographic stuff. So they have neat journals too. The journals show you just neat and unusual ideas for how to do mapping. With that, let's move on to the labs and let me know if you have any questions. Thanks so much.